if you still remember, during the class, we do the modeling for mechanical system, translational system, and then after we do the modeling, we get this state space. Okay, the next question, normally lah, for the full complete set of the final exam question, I give you a system and then you do the modeling, and then based on the modeling, you need to find the stability of the system. From this, can you determine the stability? No. So in order to get the stability of the system, you need to convert to transfer function. Okay. In order to get the stability of the system, you need to convert to the function. You must use this formula. Okay. But in this case, I give you given K equal to 0.5. The spring unit Newton meter. K equal to 0.5, FV equal to 1, and M equal to 2 kg. Example lah. Okay. So, what you need to do, you need to substitute all the values lah inside this thing. And then in order to use this formula, you must know what is your A matrix, what is your B matrix, what is your C matrix, and your D matrix. So in this case, we just simplify here. A matrix is 0, 1, negative K is negative 0.5 divided by M is 2, negative FV over M 1 over 2. This is your A matrix, or we can put it as 0, 1, 1/2, negative 0.25. This is 0.5. Is it correct? Betul kan? And then after that, your B matrix is 0, 1 over 2, which is 0 and 0.5. Your C matrix is 1 and 0. Your D matrix equal to 0, because there is no D here, is it? So now you have your A matrix, B matrix, and C matrix, with D matrix equal to 0. Okay, I give you some time to copy the information there. Okay. So according to the formula, which part you must solve first? You have C as I minus A inverse B plus D. Yes, you need to solve this one first. You need to find Si minus A inverse first. In the bracket. After you get this value, then you can multiply them together lah. Okay. If you still remember, can you help me? In order to find Si minus A inverse, Si minus A inverse actually equal to adjoint Si minus A over determinant Si minus A. Kan? We did this exercise before for the mathematics. So now, in order to find the adjoint Si minus A, you need to solve Si minus A first. You understand? So firstly, I told you that you need to get the Si minus A first. So the S is only S. The I refer to identity matrix, which is what dimension? Why the identity matrix is 2 by 2? Yes, because your A matrix is 2 by 2. The 1 0 1 0 0 1 S Si minus A matrix 0 1. So this is Si minus A. So if you solve it, you get S0 0 S minus 0 1 negative 0.25 negative 0.5, and finally this is S minus 0, you get S 0 minus 1, you get 0 minus negative 0.25 and S minus negative 0.5. Okay, this is only for the Si minus A, but you need to solve Si minus A inverse. To get the Si minus A inverse, you need to use adjoint Si minus A divided by determinant of Si minus A. So the adjoint of Si minus A, you use 3T techniques. Firstly, Si minus A transpose, you get S negative 1, 0.25 and S plus 0.5. So from here, you transpose, the row become column, the row become column. So this is the first row become first column, the second row become second column. Transpose. And then after that, you need tutup, close. The second T is tutup. So when you close S, you get S plus 0.5. If you close 0.25 here, you get negative 1. If you close negative 1, you get 0.25. And then if you close S plus 0.5, you get S. And then finally, you need to apply tanda, which is sign. The sign should be, I'm quite lazy to rewrite again. And then you just apply positive. Tadi marker macam pekat. Positive. The tanda should be starting with positive, negative. Last one. Positive. Positive, negative, negative and positive, kan? Positive, negative, negative, positive. And finally, your answer should be S plus 0.5. Negative multiply negative 1, you get 1. Negative 0.25. And here is S. So this is for adjoint. Okay, adjoint. So we go for determinant. So for the determinant, we choose any row or column that you prefer. In this case, you choose the first row, which is S and negative 1. We choose this first row. So S and negative 1. If you close S, you get S plus 0.5. And then if you close negative 1, you get 0.25. and then you apply tanda. The first is positive, the second is negative. So you apply positive and negative. Finally, your determinant is s square plus 0.5s plus with 0.25. So this is your determinant. Anyone can tell me who get until this answer? You get the answer? You also? Anyone? Okay. So for those who are not able to get this answer, after class, please see me. Okay, please see me after the class. And I will help you until you get this answer. If you don't able to do it, I think I will see you for another semester. If you are not able to do it, for sure I will see you for another semester. Okay, so now we know that our Si minus A inverse is S plus 0.5, 1, negative 0.25, and S divided by S square plus 0.5S plus 0.25. Are we finished yet? No, because our target, we want to find the stability of the system. In order to find the stability of the system, you need to find the transfer function first. Okay? So, we use this formula to get the answer. So, we just put it according to the sequence. Yeah? The C is 1, 0. The Si minus A inverse is S plus 0.5, 1, negative 0.25, and S divided by S square plus 0.5S plus 0.25. And then your B matrix is 0 and 0.5. Plus your D matrix is 0. So you need to align your information according to this formula. C, please write C first. And then Si minus A inverse, please write Si minus A inverse. And then multiply with the B, please write B. Plus with D equal to 0, 0 lah. Okay. What you need to know about the matrix must be solved from right to left. This is the matrix, how you need to solve it for matrix, from right to left. And also, you can see this is not in matrix form. Is an equation. Other than that is in matrix form. So, you can take it out first. So, you can take it out. So, you can take out the denominator part and just left the numerator part. You can do it like that, no problem. I told you that for the matrix, you need to solve from right to left. So you need to multiply these two matrices first, which is S plus 0.5 multiplied with 0, plus with 1 multiplied with 0.5. So the answer is 0. Or maybe I can put it in the S plus 0.5 multiplied with 0, plus with 1 multiplied with 0.5. And then the second part is negative 0.25 multiplied with 0 plus with S multiplied with 0.5, and then you get 1 over S square plus 0.5S plus 0.25 multiply 1 and 0. So this thing will become 0.5, this will be 0.5S. And then after that, 1 over S square plus 0.5S plus 0.25 multiply 1 multiply with 0.5 plus with 0 multiply with 0.5S. And finally, your final answer is 0.5 divided by S square plus 0.5S plus 0.25. The question is it stable or unstable? How you get the stable, unstable? Okay, because in transfer function, this equation we name as a characteristic equation. If you look at the transfer function, at the denominator part, the name of that equation is characteristic equation. If you want to know the character of, if you want to know a people, you must know the character of the people. Is it polite? Is it grumpy? Is it the people jealousy? Something like that. So for the system also, in order to know the character of the system, you need to refer to the characteristic equation. However, the criteria that we look for the system, is it stable? Is it unstable? Is it fast response? Is it slow response? Is it have very high error? Is it no error? Everything is depending on the characteristic equation. Okay, so in this case, you can check the peak time, the setting time, the stability, the percentage, overshoot, and so on. Everything depends on this. The accuracy. So normally, when you learn control, this is the thing that you will evaluate. You will analyze. Is it the system good or not good? Based on the characteristic equation lah. Okay, so the stability, the pole's location on the left hand side. What is the pole location? Using your calculator? What is the value? Negative 0.25. Plus minus? Oh, so the location is here. There are two poles, which is negative 0.25. This one should be 4.3. Oh, 0.4. 0.43. And here is positive J, 0.43. So if you factorize the characteristic equation, you will obtain two poles. The first pole is negative 0.25 plus J 0.43. The second pole is negative 0.25 minus J 0.43. And then you plot it on, what is the plane name? This we call S plane. Okay, the S plane, the x-axis, the label as real axis. The y-axis is imaginary axis. And then you plot it, you look at the two poles on the left hand side or on the negative side, is it? So if the poles on the negative side or on the left hand side, the system is stable. So according this, when the system stable, you will expecting an output graph something like this. This is stable graph. Okay, so that's why you can predict what will be happen. You know that, oh, because the poles on the left hand side, the system is stable. So you can predict the output will be like this. Okay, so let's say if you plot it, you find the system is unstable. When you plot it, for sure you will get an unstable output. Something like that. Okay. Is it clear?